Need my mug. Okay, welcome everybody. It is the top of the hour. Let's get started. Good afternoon. Welcome. My name is Alan Barr with COEH Northern California. And on behalf of the NIOSH supported education and research centers throughout the country, we're pleased to present the 2021 ERC Ergonomics webinar series. We offer a free monthly webinars on various topics on human factors and ergonomics. This collaborative effort on behalf of each ERC's continuing education program aspires to provide access to current research supported through NIOSH ERC programs. Thanks very much for joining us today. If you logged in with your registration email, you will receive a link to the recording and an evaluation form that will qualify you for a certificate of completion worth 1 CE contact hour. On October 5th, we have another webinar coming up, Promoting Sanitation, Worker Health, and Safety Through Social Enterprise, in partnership with Rachel Sklar, a PhD, and Northern California ERC. You can register for that webinar and any of our other upcoming webinars at coeh.berkeley.edu/webinars. For today's webinar, you will be muted during the presentation as usual. If you'd like to ask a question, and we certainly encourage you to do so, please enter it into the online Q&A. It's easier than the chat window. We'll save some time at the end of the presentation to address any questions you might have. As I alluded to, today's webinar will be recorded and made available along with past webinars on the COEH Northern California YouTube channel. Please like and subscribe to that channel to help us continue to grow that channel. Today's webinar, very excited to present Preventing Slips, Trips, and Falls, Current Research and Trends, in partnership with Dr. Andrew Merryweather and Rocky Mountain Center for Occupational and Environmental Health, University of Utah. Dr. Merryweather is Director of the Ergonomics and Safety Program at the University of Utah and Associate Professor in the Department of Mechanical Engineering, as well as being an Adjunct Associate Professor in the Departments of Family and Preventive Medicine, Physical Therapy, and Athletic Training. He teaches and directs research in the areas of ergonomics, biomechanics, human factors, musculoskeletal injury prevention, and human systems modeling. Dr. Merryweather obtained his PhD degree in mechanical engineering at the University of Utah in 2008 as a NIOSH trainee, yay, in occupational injury prevention. Dr. Merryweather has managed significant research projects investigating patient falls, footwear, and musculoskeletal injuries, assistive technologies for persons with disabilities, adaptive technology development, robotics, and human system engineering. And with that, it's my pleasure to hand the mic over to our guest speaker, Dr. Merryweather. It's all you.
Thank you, Alan. It's my pleasure to be here today. And hello, everyone. Today, we're talking about an important topic, preventing slips, trips, and falls. And I want to thank the COEH for organizing these webinars and really providing the platform for us to share this information. I'd also like to acknowledge my sources of funding and support as my role as Professor and Director of the Ergonomics and Safety Program here at the University of Utah. And I have no financial conflicts of interest with any of the materials that I'll share today. The Ergonomics and Safety Program at the University of Utah is part of the Rocky Mountain Center for Occupational and Environmental Health as one of the NIOSH ERCs. And we are dedicated to protecting workers and their environment through interdisciplinary education, research, and service. We also recently formed a new partnership with Weber State University, and we're excited for that. If you want to find out more about us, you can click on either of these websites. So over the next 45 minutes or so, we will discuss the gravity of slips, trips, and falls. Why do people fall? What do the trends in STFs over the past 10 years teach us? How do we recognize STF hazards and prevent them? And we'll also peek into some of the future work and current research aimed at reducing STFs here at Utah. But first, Let's talk about or ask a few questions. When was the last time you slipped, tripped, or fell? If you haven't experienced an STF recently, you probably know someone who has, so think about that instead. The image on my opening slide is actually from a project site where I was helping erect a large steel building earlier this summer. And we were installing metal roofing, and the wind overnight out of the canyon had blown a lot of dust on the roof panels that were on the ground ready to be installed. To make matters worse, crops were being harvested and large plumes of dust were already in the air and settling on top of these roof panels. So in the morning, I climbed out on a lift and onto the roof, and I pulled up one of the 27-foot panels using a pulley and a rope and positioned the panel on the purlins to be screwed down. While squatting down using my impact driver, I applied force downward on the fastener. And you may or may not remember, but from Physics 101, you probably recall something about Newton's laws. So my force applied downward, reducing the normal force of my boots, and the invisible dust later made the already slippery roof even worse. And before I knew it, I was sliding down the roof, picking up speed and helpless. So don't worry, this does have a happy ending. I had a safety tether, and once the slack was gone, I was able to regain control of what I thought was going to be the end. But this experience, particularly just a few months ago for me, motivated my topic today. So I want you to think about your experience. If you had an STF, where did it happen? The activities we choose and the environments we operate in can also contribute to an increased risk for a slip, trip, or fall. So think about your experience. How did the STF happen? Were you in a hurry? Did you take extra risk? What were you doing when it happened? Many STFs don't result in a reportable injury, so the numbers that we have are most likely underreporting the actual frequency of STFs. In your experience, have you ever been injured from an STF? What did your recovery look like? Do you still have any physical impairments or difficulties linked to that experience? I ask these questions because as we look at the history of falls, in the past, most fall incidents were considered normal events or even unavoidable accidents. Even now, when falls are considered predictable and preventable, when someone falls, if asked what they think contributed to the fall, many still either blame themselves or say it was an unavoidable accident. Looking over the past decade of STF injuries, we see that the total number of STFs hasn't been dropping as we hope it would. In fact, the number of non-fatal STF injuries resulting in days away from work has increased. Why is that the individual often fails to attribute the fall to other modifiable risk factors, such as the environment, placement of handrails, lack of mobility aids, PPE, assistive devices, and so on? Individuals continue to seem to place blame on themselves for these, what they consider accidents. So the big question really remains, if STFs are truly predictable and preventable, why are falls so prevalent? Let's look at some recent data. We can see some disturbing trends and rankings of falls. Regardless of industry, falls on the same level and falls to a lower level consistently rank in the top 5 causes of loss across all industries. STFs aren't only a construction problem. What's perhaps even a little more concerning to me is the year-over-year consistency of the numbers and rates of falls across these industries. Keep in mind that this graph just represents the total number of falls and is not a rate value. However, looking at the number gives me an appreciation for the actual number of people being injured from STFs. These are those workers who lose time at work because of an STF-related injury. We also see that the total numbers are associated with rates. If we look at the rate connected to these numbers, effectively we see general trends and the story is about the same, whether you normalize to the number of people in that industry who are working or just look at total counts. In total industry, according to the Liberty Mutual Workplace Safety Index, falls and falls on the same level and falls to the lower level represent the second and fourth highest sources of loss and account for nearly 28% of all direct costs for disabling injuries in the workplace. In construction, we see that falls represented a higher overall percentage of costs related to loss at almost 40%. Yet, as we combine both fall categories, so falls on the same level as well as falls on the lower level, we see similar percentages for professional and business services at 35.7% of all costs. In manufacturing, the numbers are less, and falls from height don't make it to the top 5, yet nearly 15% of all costs are still associated with a fall on the same level. However, in healthcare, even without the falls from height on the list, a quarter of all costs occurs from falls on the same level. There's a similar story with the retail industry, but falls to lower level do show up again here, with 25% of all costs associated with a fall. So if, and I want to emphasize if falls are indeed 100% preventable, how can we explain these data and these trends? Why the consistency across industries? What's going on? Again, in industries, rankings of cause of loss, top 5, nearly everyone has falls on the same level or falls to a lower level as one of those top 5 causes. So perhaps maybe we aren't doing enough research. I don't think this is the root cause of the problem. However, I welcome more funding to study slips, trips, and falls. There seems to be a lot of energy and money being spent on the topic of STFs, as shown here. And it's not isolated to a specific discipline. So across all of these articles being published in the academic and scientific communities, we see that those are distributed across various disciplines within science and research. So there are many qualified and smart people looking at this issue. So perhaps maybe the problem is that STFs are complex, similar to complexities observed in the study and prevention of musculoskeletal disorders. There's not really a specific formula for an STF. It's not reasonable. In other words, one size doesn't fit all. There are major risk factors that have been identified by NIOSH and the CDC and others, including the condition of floors and walkways being contaminated, irregularities of surfaces, environmental conditions, lighting, handrails, clutter, and other hazards like tripping hazards in stairs and ladders. But falls, just like musculoskeletal disorders, are multifactorial. There are task-related factors, environmental factors, and personal factors that all contribute to overall fall risk. So again, there's not a formula that includes all of these factors to generate an overall hazard score or produce a value we can assign to risk. Some of these factors are shown here. Given the multitude of factors, how do we identify hazards and control risk, given the complexities of STF prevention? Perhaps looking at these factors again can spark some thought and new ideas. So let's start by looking at personal factors. How can we influence better health and healthier aging? Can we use our knowledge of anthropometry and biomechanics to improve the fit between tasks and capabilities? Or is there something about fitness or interventions to promote healthy aging that can also move the needle in fall prevention? I've yet to come across convincing arguments that we can control nature and the elements. So perhaps that's off the table. But how do we manage risk associated with weather and other conditions that are out of our direct control, such as ice and water or heat? What about behavior? Does our safety culture and safety climate need an overhaul? How do we promote safe behavior and best practices to prevent falls? As engineers, what's the obligation to create safety standards and guidelines for design, including promoting ethics for safer designs that identify STF risk factors and acknowledge this multifactorial nature of the falls? And then there's a host of other factors that can also contribute to an STF. So what do we do with these? How do we handle these other factors? Let's look at aging as one of the factors that I've been involved with studying in my career. So age creates major mobility challenges. General instability is often affected through aging and further compounded by reduced vision, peripheral sensation loss, changes in strength, reaction time, and vestibular function. The numbers of falls worldwide is really staggering, with millions of people falling annually, and these numbers correlate with the age of the population. There's also higher rates with aging populations observed, especially in developed countries. So until we discover a fountain of youth or can put a pause on aging, what practices should we be teaching and following to improve aging resilience against slips, trips, and falls? Another environment I've been involved with, and I spoke on a webinar recently about this, was work vehicle environments. Millions of tradesmen and women and field service workers are working from a vehicle. And in one study we conducted, just the acrobatics involved with retrieving tools from the back of a standard pickup truck was astonishing. Some of these might even qualify as new Olympic events. So how do we deal with these fairly uncontrolled and uncertain types of environments? In commercial trucking, where there's more regulation on the vehicles, we also found that most STFs occurred while drivers were getting into and out of the cab, not even doing any work, in quotes. What's the message to cab design engineers or vehicle engineers? If you or I had a probability of severe injury every time we got into and out of our personal vehicles to go to and from work, there would be a significant outcry for change. Yet these employees have that risk factor. So it's not all bad news. There's a lot of good news and important outcomes that have come from research. And some of those form the basis for guidelines such as these: preventing falls from equipment. These guidelines have been proposed to reduce the probability of an STF, but most of them require compliance and rely on individual behavior rather than an engineering control. As health and safety professionals, we recognize the value of following the hierarchy of controls, where behavior and relying on an individual to make a choice is not nearly the level we want to achieve. Another source of fall risk are irregular surfaces. Irregular surfaces, both inside and outside, are a challenge. This was one of the problems that I faced as a young PhD student, and I was asked to quantify the changes in lower extremity biomechanics during gait on railroad yard ballast, both large and small ballast, and on flat and slanted surfaces. It wasn't too surprising that there were differences between the conditions, but the trade-offs between the size of rock, degree of slope, and location of the rock in the railroad yard was complicated due to other requirements for safe train locomotion, including drainage and structural support for the tracks. In another environment, such as mining, we see similar challenges. In addition to irregular terrain, there's often restricted space and poor visibility that further compound the risk of STFs. We've also looked into the effect of flooring surface transitions and the influence it has on gait. For some, especially the elderly, a small change in surface height, friction, or compliance can create a balance perturbation that results in a failed recovery and a fall. Minimum toe clearance or foot clearance during gait can help us predict the risk of an STF. So we studied these surface transition effects for common indoor and outdoor surfaces and how individuals who with Parkinson's disease are at an increased risk, and we compared those to age-matched controls. Here you see the effect of an outdoor surface transition on gait of a person with Parkinson's disease. They're transitioning across a surface covered in artificial turf onto a surface representing a cobblestone walkway. And it's clear to see the obvious change in modification in gait and the approach taken by this individual in transitioning those surfaces. If we illustrate some of these differences by observing the ground reaction force butterfly curve, that's the light blue fan shape you see on the figures, it's obvious that the person with PD walks with a much more impaired gait, just in general. The flow is disrupted and the movement of the center of mass is more jerky. This is for the level smooth surface without any transition. If we compare that, again, observing the ground reaction force butterfly here to an irregular surface, in this case cobblestone, we see a much bigger change and effect it has on the biomechanics and the kinetics of motion for the person with PD. You can observe also the amount of knee flexion and neck flexion, where the person with PD is targeting their steps and being much more cautious about where they place each foot. This is another reason why vision and vestibular impairments can compound the problem of fall risk with aging. So in some efforts to help us understand the role of various gait changes, such as what we see here with Parkinson's disease, we also look at surface conditions and footwear. In these pictures, we see a robot in a robotic test bed that was built by our group at the University of Utah that can replay recorded gait from a motion capture lab and run simulations to evaluate interactions between these factors. So between the footwear, the shoe, and the gait style or gait technique. And this is a video of that robot replaying a healthy heel strike and toe off on a force plate. So using this as a very repeatable platform provides us with the ability to study things that otherwise take days, months, or years to study with different populations. Also, sometimes you may find that training for slippery conditions and raising awareness among your workforce is an important intervention that can have a significant effect on the numbers of slips, trips, and falls that are seen. For example, we can observe gait adaptations in the presence of a slippery condition or perceptions of a slippery condition. If you live in a place where you deal with ice and snow in the wintertime, you probably know what I'm talking about. We've all adjusted our gait and modified the way we walk if we walk outside of work and there's ice or snow in the parking lot. We modify our stride and cadence, and we may even alter our biomechanics to generate a safer gait due to a difference in the walking environment or the surface condition that's perceived. Whether that's shorter steps, shorter stride, or rotating our feet to increase evasive support, all of these modifications can help reduce the probability of a unrecoverable slip. What about environmental conditions? In the environment, we find that there are many factors that contribute to the risk of a fall. For example, we can see a number of risk factors in the images that I have on this slide. In the case of residential roofing and shingling, as well as concrete work, and then the type of surface that's in the workplace can also contribute to the probability of a slip. When we observed this among our truck drivers, in the data I presented earlier, we found that they claimed rain, snow, and mud were seen as a contributing factor to many of the reported falls from the cab. We also see that working posture and ergonomics can play an important role in identifying slip trip potential and preventing it. So one of the challenges that I faced as someone who works a lot with industry and partners trying to prevent injuries is the fact that doing risk assessment, performing a job hazard analysis is time consuming, requires lots of resources and specialized training. So recently I've been fortunate to work with the technology from Analog Devices called the Stitch to measure posture and to quantify the frequency and amount of hazardous movements during a task is shown here. So in this task, there are 3 examples of a soldering task with low, moderate, and high risk movements. And the Stitch is the black shirt that's being worn here with 7 inertial sensing units to generate upper body kinematics, as is shown in the top video. And then a RULA score is being computed and accumulating a risk profile for the task, which is what you see with the histograms that are changing color based on the frequency. So technologies like these are becoming available using wearable devices. And I think as some of these things start to catch on, it may help us move the needle in our fight to prevent workplace injuries because we have a greater understanding of what's going on and how that's contributing to an increased level of risk. So now let's talk about footwear. We can also see the effects of footwear on fall risk. Dr. Kurt Beschorner and his team at Pittsburgh are producing a lot of quantitative wear models and analyses of various types of footwear and tread patterns to help inform slip resistance footwear design. Even without expensive instruments, you can get a sense of whether or not your shoes are putting you at an increased risk of slipping. As shown here, using a method of placing pennies on the tread pattern of a shoe, looking at how much of the tread pattern is worn away based on 2 pennies is a simple approach at identifying shoes that should be replaced. So I want to ask you a question listening to this webinar. Have you checked the tread of your footwear lately? Well, in preparation for this, about 30 minutes ago, I decided to check my footwear. And you can see here that I've exceeded my mileage rating and I need an upgrade. So I know what I'll be doing this weekend. What about trip hazards? Different workplace environments have different types of trip hazards. We can see from some of these pictures that cords or clutter in walkways can increase the risk of trip falls. We also see uneven surfaces, stairs, tools and equipment. All of these trip hazards are often related to clutter and obstructions, but they can also be something as small as a transition between surfaces or an irregularity in the surface. So you can probably spot some of these trip hazards in these images. So now I ask the question, how do we prevent slip, trips, and falls? By improving general health. First, staying hydrated and eating good foods can increase your alertness and the awareness that you have around you. Exercise and maintaining flexibility and strength promotes strong hips and knees, providing an improved probability of recovery when a slip does occur or when our balance is perturbed. Additional work has been done that shows balance improves with low-level impact exercise, such as cycling and walking. Managing fatigue and stress is also important because it helps improve focus and reduce distraction. Another thing is being aware of the types of medications that are being taken and the effects of those medications on something such as dizziness and the effect it has on balance. Another thing to consider is vision. Be aware of the challenges with bi and trifocal or progressive lenses, especially on stairs, and particularly with an aging workforce, the degradation of vision as a function of aging. There are many factors like this that seem relatively simple, but in essence, their effects can be huge. Now I want to talk about some futuristic research or research that's a little outside of the mainstream. There are many other projects that we could discuss and other sources of data. As we saw, thousands of papers are published just in the past 10 years or so on the topic of slips, trips, and falls. But as I shared, there doesn't seem to be a lack of interest and research on the topic. And some of the work that's being done in Utah has involved things such as virtual reality and robotic smart shoes. We try to rethink the ability to provide training and awareness and increase our ability to study environments without the challenges involved with creating those environments physically in a laboratory. So using the advantages of virtual reality and some robotic smart shoes that can portray or present haptically different terrains and different surfaces, we can get a better, more controlled evaluation of some of these more difficult areas to study in the field. Also, this is recent work that we've published that takes into consideration both intrinsic and extrinsic factors on performing a risk assessment for falls within a hospital patient room. We generate heat maps based on layers of risk that are assigned to these factors. So in what's shown here, you can see lighting, supporting objects in the room, flooring, and door operation as 4 layers to the fall risk. The next layer includes a probability generation from frequency of movements in the room to produce the overall risk room score that's shown in the heat map on the right as a baseline. With these types of fall risk algorithms, we're now working on optimization methods to help us understand physical relationships between objects and how those relationships either increase or decrease the level of risk for falling. Additionally, kind of based on some of these models, we've been programming personal assistant robots that can help to manage risk for individuals who use walking aids. This was particularly targeted for hospitalized patients who are unable to transition the distance across the room to use the toilet from the bedside. These tools, again, are kind of futuristic and outside the mainstream. But with these tools, we might be able to start to nudge the needle further towards reducing slips, trips, and falls. A lot of work is still needed, but these are the kind of projects that we're doing here in Utah in this area of slips, trips, and falls. I want to summarize a few things here before we have our discussion, and that is, today we looked at the grim numbers of slips, trips, and falls and the related injuries in our workplaces. We also talked about the commonality across industries for STFs. These numbers are likely much larger, specifically if we consider the number of STF injuries that happen outside of work and those that aren't reported because they don't result in a reportable injury. So how can we identify hazards and control risk to prevent slips, trips, and falls? One of the simple things to do is perform an inspection. We're unable to identify a hazard and measure the potential for a STF if we don't see the hazard or if we don't look for the hazard. In addition, we need to perform these inspections and then follow design standards to make sure that our environments are conforming to the specific requirements that have largely been created from research and evidence that will help us ensure a safer working environment. Oftentimes, the organization and cleanliness of a workplace is directly associated with slips, trips, and falls. So does your workplace need housekeeping? We talked about footwear. Just like none of us would likely send a loved one out on the road during a winter storm in a vehicle with poor tires, we should encourage and promote the use of proper footwear among our workforce. We could also consider a footwear maintenance schedule to prevent footwear from outliving its safe tread life, similar to what's already done with fleet vehicles. Another thing is simply increasing awareness and promoting safe behaviors. These types of awareness campaigns that you're probably familiar with, particularly in the construction industry, can improve safety culture and influence personal behaviors that contribute to slips, trips, and falls. So finally, making a plan to learn how to identify slips, trips, and fall hazards and control risk is important. I want you to take a moment today to reflect on what we've talked about and take action on any thoughts and ideas you've had while listening to the webinar. You can control and prevent slips, trips, and falls. But the question is, how do we do this? I didn't mean to introduce the topic with the numbers showing increases in trends and basically little change over the last 10 years in numbers of injuries across industry sectors. But the reality is that's the truth. That's the problem we deal with now. So I think it's time that we make a change in our approach. And each of you has an opportunity to look for ways to control and prevent slips, trips, and falls. A simple thing to do even today would be something such as looking at your own footwear or looking at the footwear across the employees where you work, or taking care of clutter and looking at housekeeping. A wise man once said, by small and simple things, great things come to pass. You can do more than you think. And as always, wear fall protection when working at heights. Again, I want to thank those who support this work in the Rocky Mountain Center. And I think maybe I've given a lot more time than anticipated for questions, so hopefully that's okay.
Thank you very much, Dr. Merryweather. Yes, that is fine. We have plenty of questions for you. I think I'll exercise my prerogative and ask the first one. I'm just curious for my own sake. Are you aware of slips, trips, and falls studies with respect to exoskeletons of any sort, or any other sort of human augments in the workforce?
Yeah, thanks for the question. With regard to that, I haven't seen those studies with the exoskeletons that we're probably thinking about, including the upper limb exoskeletons and lifting related exoskeletons, but there are exoskeletons in the rehab world, and there are research studies on exoskeletons in rehab, including the Endigo and the Rewalk, but that's probably a little bit different than the question you're asking. I'm not aware of those studies that have been conducted right now with the more popular exoskeletons that are being used for overhead work and for lifting.
Thank you. I'm really was delighted to see you emphasizing personal factors when offering up some solutions. And I would just like to throw one more into the mix for your slide. And I think sleep is a really important one that was not mentioned there, but the rest of them were, I think, really important. And it's fantastic that you're putting some responsibility out there. Do you know if any of the personal factors are recorded in the injury data?
I'm glad you asked. When I pulled all the data from the BLS in preparation for this talk, there are some additional data on time of day and week, even time of day of week, and some other things like that. When I looked at those data, I didn't see any notable trends associated with the slips, trips, and falls. But in terms of like personal data recording in the BLS, all of those data, I'm not familiar with them if they are available and haven't ever seen them.
Okay, thank you. All right, let's jump into some participant questions. I'll read some of these to you. We've had a number of trips, falls during COVID-19. Workers blame reduced visibility due to face masks, but I think it's a combination of that and distraction. What is your opinion?
I think that's a great question, because certainly we've had a lot of challenges during the COVID-19 pandemic. Depending on the type of face mask, and I wear corrective lenses, so all of those who are with me on this can vouch for what I'm going to say here. As you're breathing or as you're breathing with your face mask or your face shield on, it ends up fogging up your corrective lenses, further reducing visibility. In terms of the distraction part of that question, I'm not exactly sure what's meant by the distraction, if it means the distraction of the pandemic in general and an elevated level of stress. I believe those factors of distraction can certainly increase or decrease our awareness and increase the chance of a slip, trip, and fall.
Thank you. Yeah, that makes sense to me. Is there a threshold, a coefficient of friction threshold for certain surfaces? I think this person is asking specifically, perhaps with respect to hospital floors, where a certain type of footwear becomes PPE, strictly with respect to slips, trips, and falls.
Yeah, so there are guidelines for the coefficient of friction for flooring surfaces, and those friction requirements are about 0.3, 0.33 is what's been seen in the literature, and there are tribometers that are used to certify those flooring surfaces and standards that govern the manufacturing of those flooring surfaces. So particularly with hospitals, it's been a big topic. And one of the challenges with hospitals, particularly in the patient room, dealing with different bathroom designs where the shower and the toilet room are kind of connected without specific thresholds. After patients are bathed, there's a lot of water on the floor there that can completely change what the coefficient of friction is on the floor. So some of the work that I mentioned from Dr. Kurt Bashorner in Pittsburgh has done a lot of work in modeling these interactions between the fluid layers on the floor and the different tread patterns for slip-resistant footwear, and some of those effects, and even the effect of wear over time with that footwear and how well it performs. And I would encourage you to look at some of Dr. Bashorner's work for more information on that topic.
Thank you. A couple of questions related to that footwear. A couple of listeners would like for you to expand on how you are using your penny method when evaluating your tread.
Yeah, that's a good question. It's not my method. I can't claim responsibility for that. The penny method, looking again at that, let me pull that up just quickly here. Essentially, you place 2 pennies, and there's also a quarter method. See if I can get rid of that. Based on the amount of coverage of the pennies, and if you're touching the tread with the pennies or not, those 2 pennies together can indicate that's too much area. If that much area is worn out on your tread, it's time to replace your shoes. That's kind of the simple qualitative assessment of whether your shoes need replaced or not. And we could discuss the fact that where those pennies are placed on the shoe changes how much risk may be associated with the wear of that tread. But in this case, we're just looking at 2 pennies. If you can place them on your shoe and you have tread touching those pennies, that's a qualitative assessment that your shoes may be okay.
Excellent, thank you. In an aging workforce, how do you address the combination of loss of muscle mass and strength, decline in visual acuity, decline in balance, and an increased use of medications?
How do you?
Yeah, I'm not sure how you're going to answer that, but perhaps you have an opinion on what we're doing collectively to address this, these obvious conditions associated with an aging workforce.
Yeah, so I'm not really humorous in kind of nature, but my comment about the fountain of youth, we haven't found it yet. So aging is going to affect all of us, and is affecting all of us. I think it really comes down to this principle of the hierarchy of controls. If we understand the ability to reconfigure and design our environments with the knowledge that the human in that system has changing capabilities. When I talk about ergonomics, I often relate it to a simple Venn diagram with 2 parts. There's a part with capabilities, and there's a part with requirements. So if the requirements of the work are not changing, but the capabilities because of aging are changing, the intersection between what's capable and what's required gets further and further apart. So there's less intersection. And ideally in ergonomics, we're trying to have the capability of the individual be larger than the work requirements, or as large as possible, to reduce that mismatch that exists between people and the work that we do. So my comment on that would be understanding those changes in function, in strength, in vestibular, in vision. Knowing those changes, how do we reflect that in our job tasks? Can we change the work and engineer the work to be better suited or better accommodating for an aging workforce? And I think that's where the answer lies, in trying to figure out how to reduce the risk because of all these changes that occur during aging.
Perhaps that explains why we're seeing that slope sort of increase, well, at least the numbers increasing. We're not necessarily addressing that sufficiently. That could be one explanation. As we age, we're not taking those steps to account for that aging workforce.
Yeah, I think that's perhaps part of the problem. The other thing I didn't show with the data that I presented today is that while the aging percentage of aging workers is increasing, the total numbers of slip, trip, and fall injuries among that older age group is actually lower. But the problem is, when they do happen, the number of days away from work from an injury are higher because of aging. And we know as we age, we don't bounce back quite as quickly as we did when we were young. So there's that issue as well. It's kind of a complex set of problems. Yeah.
Sure. Okay, let's get some more here. How can the common person evaluate commercial claims that footwear or flooring is actually slip resistant?
I wish I had the right answer for that, because I've been extremely frustrated about some of those claims as well. And there's lots of other claims related to safety, gear, and PPE, as well as ergonomic products, right? That there's not a clear way to evaluate that. But again, I'll point to Dr. Kurt Bashorner and some of his work at Pittsburgh, where they're building computational assessment tools and methods and providing guidelines for how to select proper footwear that does do what it's claimed to do. And I think that's I wish I had a better answer. It's not an easy question, because there's lots of claims for things that perform under ideal laboratory conditions in a specific way. So I'm not claiming that these companies false advertise, but I am claiming that when you put the footwear in the real world, they're not performing the way they performed on their test fixtures in the laboratory that were used to certify them.
Excellent, thank you. Someone's asking if you have a link to a resource for to learn more about the Stitch wearable.
I do. Let me go back to that slide, and I think, Alan, these slides will be made available. Is that correct?
Yes, thank you. We'll make a three-slide per page PDF. Okay. that can be requested from COEHCE@berkeley.edu.
Yeah. So for the question about the Stitch device from Analog Devices, the email on the slide here is the best place to find out more about their technology and what it can do.
All right, excellent. smart.clothing@analog.com. Thank you for that. Okay, let's see. There are a couple of questions regarding low lights and strategies to manage low light environments like theaters and galleries and so forth. Do you have any thoughts on that topic?
Well, thanks for the question. Smart lighting is probably one way to address this that is not being used as frequently as it could be. So by smart lighting, we know in a theater, there's already strip lighting and some things like this that are supposed to help. But back to the comment about aging specifically, there's change in visual acuity that's also reduced with lower light levels. So for that group of people, these strip lights that may be fine for younger, healthier eyes don't provide nearly enough illuminance for someone who has some visual disparity. So I think smart lighting could help, or more targeted task lighting, if you will, for individuals who are in an environment that's dark, but I don't have any good solutions there or haven't seen any.
Okay, thank you. Another participant mentions that they have slipped going downstairs on several occasions, and they want to know, do you know what the contribution to workplace slip, trips, and falls is that's attributable to stairs in particular?
Thank you for asking. I don't have numbers on hand to share, but there are studies published on differences in stairs and ramps. And we certainly see a much higher increase. In fact, there's an increase going downstairs than going upstairs. Greater numbers of falls occur downstairs. You can imagine why, with gravity helping out with that fall, more so than going up the stairs. But I don't have numbers to share of what that percentage looks like. Although injury-wise, the injury severity is usually greater on stairs, as you can imagine, than it would be on a level, flat surface. Similar to a fall from height, right? The penalty of a fall from height is greater than the fall from just standing on the ground, and that penalty shows up in terms of costs for injury.
Excellent. I guess beyond inspections, a participant is asking, what resources can you recommend for practitioners on conducting a good evaluation of slip, trip, and fall risk in a workplace?
Well, there are some checklists and survey tools that have been published that are available for you to use. And Alan, I can also try to pull some of that material together if you want to make it available with the slides. But that's a place I would start. Some of these need to be tailored specifically to your individual workplace, because as we see with the industry data, regardless of what your workplace looks like, this is a problem, but the factors that are generating that problem are different, whether you're in construction or in a warehouse. All right, some of those factors are very different in an unstructured outdoor environment compared to a very structured indoor environment. So we need to be looking for specific factors that are more likely to be there for the type of work that you do and that you're trying to figure out how to prevent these injuries from.
Okay, thank you. Here's a question relating to increased density in hospital rooms, specifically with the surging demand of our ICU rooms due to COVID. There's a thought of placing 2 beds in a single room or 3 beds in a double room. Have there been any strategies to reduce trip hazards associated with various equipment being introduced in tight spaces that require movement, assuming that booms are already in use? I know that's a pretty targeted question.
Yeah, thank you. That's a big deal. And to my knowledge, that specific question hasn't been asked when looking at this problem we're facing with higher density, cluttered, congested hospital rooms, particularly where a lot of emergency care is being done and it's not a general patient room. More of the work that's been done in numbers of beds inside of a patient room, between 1 and 2 beds, has not looked specifically at the issue of the clutter that's derived. But I can say a few things about, just go here to this upper figure that you can see with the heat map. So some of the challenges right now faced by patients, I'm speaking of patients, and you're probably thinking maybe somewhat more of the workforce that's taking care of those patients, and the clutter and trip hazards and so forth there. So that's a different problem. But here in this example, you can see where the hospital bed's located. It's a typical hospital room, and there's a long distance for the patient to make it into the bathroom. So perhaps having more things for a patient to hold on to actually promotes the stability of the patient, because there aren't grab bars or other things to hold on to in this 3 or 4 meters sometimes from the edge of the bed to the bathroom. But to your question, I think I'm not aware of those data. I don't think it's been looked at. It would be a great research topic to investigate. And I think with some of the tools that our team's been working on for patients, we could flip that over and look at fall risk for the care providers and the different activities and frequencies of movements inside of those spaces to get a better sense of how to optimally arrange those beds to minimize the potential for a hazard. But again, there's lots of factors involved, the types of equipment, for treating COVID patients specifically, and different hardware needs that they have may further kind of complicate that.
Okay, thank you. Someone's curious about slip, trip, and fall simulators for large-scale employee training, and I'm not sure if you're familiar with any, but if you are, does the evidence support the investment for these training devices?
Good question. So the simulators I'm familiar with, I've used them. I'm not aware of any long-term studies that show any meaningful benefit. So I can't really speak to whether those have true value, but they certainly raise awareness and give you an appreciation for modifying behavior, changing, gait if you encounter a slippery surface, or if you're carrying objects and stepping over things, or stepping up or walking up and down stairs. Those different training activities can certainly help raise awareness to the employees, but whether there's a measurable effect, I haven't seen those data.
Okay, thank you. And what about footwear weight? Any studies that you're familiar with on, I wear steel toe boot at work.
Yeah.
Pretty heavy, size 14.
Uh-huh.
Any data suggesting that there's increased risk with a certain weight of footwear?
So NIOSH has done some of that work, particularly with first responders and firefighters, looking at the weight of the footwear and how it changes, like minimum toe clearance, one of the values that I showed on a slide. So there are, right, I think we could say it's not completely clear in a simple laboratory study because there's an overcompensation for the heavy footwear, and it's not as measurable using a metric like minimum toe clearance. The problem, or the issue, comes with fatigue. After many steps, it's just a simple work problem. You're lifting more weight, you're burning more calories to do that work, and you're fatiguing the muscles that are required to maintain that safe clearance. So workwear and the weight of that workwear certainly has an effect on fatigue, which then has an effect as well on slips, trips, and falls. And that work is published in a few studies, at least that I'm familiar with.
Thank you. We have time for one or two more here. I'm not going to get to all of these, just so you know. You can reach out to Dr. Merryweather. His email was provided in the splash screen of the slide, I believe. So let's see. Is there an STF risk model that combines various factors to assess an individual's STF risk? Now, I know you said there was no formula per se comprehensive, but surely there are some characteristics that we can plug in a first order model or some sort of first order estimate of the risk in an environment given certain factors present.
Right. So I wish there was a recipe. The closest thing to a recipe that I'm familiar with is in patient care and preventing patient falls. There's a number of fall risk assessment methods where you plug in these values from an individual. So they're almost all personal or intrinsic factors that go into these risk assessment methods and models, and they give you a score of the kind of the score of how much risk that person has. And so in healthcare, it's used. I haven't seen a similar formula or a similar worksheet for general industry or any specific injury industry directly that accounts for both the environmental hazard or these extrinsic factors as well as intrinsic or personal factors. I haven't seen that personally, but something like that exists in healthcare for patients and preventing patient falls.
Okay, thank you. Well, we are about out of time. I just want to wrap up here. You can learn more and register for our upcoming events at coeh.berkeley.edu. You can also subscribe to our YouTube channel where you can find recordings of previous webinars and other events. And as a reminder, if you logged in today with your registration email link, you will receive an evaluation form that will qualify you for a certificate of completion worth one continuing education contact hour. If you have any questions for us here at COEH Northern California, you can drop us a line at coehce@berkeley.edu. That's coehce@berkeley.edu. I want to thank Dr. Merryweather very much for an excellent presentation today. We really enjoyed having you. So with that, Dr. Merryweather, do you have any final remarks?
Well, thanks for attending. If there are questions, you know how to reach me, and I'm happy to respond.
Excellent. Thank you. And thank you everybody for attending today. And we'll see you at the next one. Bye.